All right, my name is Sam, and I'm going to be presenting on the gas turbine results that Group 1 had done last class. And so there's a couple of data points that we had to gather in the moment. So for this experiment, we actually were using pure kerosene, which was different compared to the other groups. And so we found the energy per unit volume and the density of that, and that was just looking it up online. And then the static pressure for the day was about 29.73 inches per mercury of mercury. And so those points come in later. But so there's going to be a lot of graphs, and they're going to look generally like this all the time. So we had a graph, the compressor inlet and outlet pressure and temperatures. So I have those side by side here. You can go to the next one. Like I said, now for the engine pressure and temperature. And this is the one that starts pulling the air in on the front. You can go to the next one. And then, so this is the generator. This is the one that's going to be creating the energy. All right, and so the fuel flow, I was talking to Edison about this earlier. Our data looked like a bunch of noise. It was all extremely small, kind of oscillating around zero. So there was probably something wrong with the sensor itself. Other groups got something much greater than this, and so I did the calculation still, but I just wanted to point out that everything dealing with the fuel flow rates are going to be wrong, but the important part is the equation that I use. So you can go to the next one as well. And so more graphs. We have the both turbines RPMs. And so this is our engine, turbine 1, and this is turbine 2. And so this is where we started activating the load lever. So, while this one is running, this one wasn't until we activated the load lever. And then you can start seeing how fast it's going. The next one. All right, and so these are the outputs, the voltage and the current outputs of the generator. And so they kind of have the same trend that the RPMs did. The power output along the same lines, kind of different values, but kind of the same behavior and curve of the voltage and the current. And so I think our max was around 12,000, which we kind of got there at the end. And most people don't know how well James actually managed to manipulate the levers, but he was the only group. We were the only group not to flame out. And so he was very proud of himself for that one. And so I would say that this data is actually fairly well just because of James's excellence. All right, so I put it in a table. Some of the important points, we had to find the max engine RPM and find the correlating data that went with that. So I have that graph, and you can see that the flow rate was 0.002, which I think Cullen's group had around 12 liters per hour. Go back to that one. And so, and then these are the pressures and temperatures at each inlet and outlet for the compressor, engine, and generator. Go to the next one. All right, so calculations, I pulled the temperatures at each point, and the points are listed here. And so I went and found the enthalpies. The enthalpies, comparing it to the other group's results, it followed the same trend where it was increasing. But here at 0.4, I believe that the other groups had one greater than 3, where ours kind of started to descend there. So that was something that was a little different compared to the other group's results. You can go to the next one. All right, now doing the calculation aspect. We did a lot of specific work, which was just taking those enthalpies from different points and subtracting them. And then for the specific energy, finding like the heat added by the fuel. We got enthalpy 3 minus enthalpy 2. So that was kind of like the work in, the energy in. And so we had to also find the energy of the whole cycle, which is here, and then the free turbine, which is there, and you can see the corresponding numbers with the plot. Go to the next one as well. And so we had to find the efficiency of the cycle, and ours was a bit higher than the other groups. and I felt the best way to display this data was by using our friend from the lab manual. And his twin, of course. You can go to the next one. All right, some more calculations. So this is where we started using the atmospheric pressure. And so we had to calculate the air density on that day. So using the pressure and the gas constant and the temperature on that day, we could find the air density. And then the velocity, we're using the pressure at the inlet of the turbine and then the density that we just had found. Volumetric flow rate, that's going to be using the area, which I assume to be about 6 inches to find that area of the turbine inlet. And then the air velocity that we found. And then mass flow rate, same kind of idea, using the data that we found previously, plugging it in. And so we got a Mach number of about 0.24. I thought this data looked fairly accurate, or I guess I should say believable. There wasn't anything that really stuck out as wrong to me. So then we had to go identify a couple of points where the load lever was pinned, the max excitation, and min. And so basically I went through the currents that were produced in the data sheet and found where they were maximized and minimized. And so later we'll see that for the current graph. But and then I went and labeled each point. So we have the yellow is pinned, gray is min, and then the orange is max. So we can see the corresponding values on every plot at those particular points. So you can go to the next one. And so like I said, with the voltage, for the min, I didn't include this portion because the load lever wasn't activated. So I kind of took it after the pinned point is where I started looking for those min and maxes. And so you can see that our max is right about at our highest point and our min is just about at the lowest point. And so once again, the power that corresponds to those particular points. Go to the next one. All right, the fuel flow, once again, I marked it down, but this graph isn't exactly a good representation of what actually happened. But just for the sake of procedure, I did it once again. All right, so calculations, we had to do calculations at the pinned and the max excitation and min excitation points. So I just highlighted in red the things that were affected by the flow rate, so y'all could take those calculations as a grain of salt. But we went and found, most of these you just had to go find from the data tables. There was some calculations like the speed ratio, which we just took the engine speed divided by the generator speed. And then the power specific fuel consumption was the flow rate divided by the power outage that the generator was producing. And so it's kind of a comparison for those points where we had our markers of kind of all of that combined into one table. You can go to the next one. So, and then once again, these are for our max excitation points, same data. And then the next one is for our min excitation. But same procedure for each one of those, finding and gathering that data. And that's it. Any questions?